In a regular computer, the switches are completely independent. One switch doesn't care at all what the switch next to it is doing. But in the quantum playground, we have a very special gate called the CNOT gate, which stands for the controlled NOT gate. This gate does something really fascinating to me. It basically ties an invisible thread between two completely different qubits. We call this connection quantum entanglement. Imagine you have two separate spinning coins. You put one coin through the CNOT gate and connect it permanently to the second coin. Now their fates are completely locked together. If you take one of those spinning coins, put it inside a rocket ship, and fly it all the way to the other side of the universe, it stays connected to the coin left behind on Earth. The exact millisecond you slap your hand down on the Earth coin and force it to stop spinning and become heads, the spaceship coin instantly stops spinning at the exact same time and becomes tails, no matter how many millions of miles away it is. The CNOT gate allows quantum computers to link millions of possibilities together, creating a massive, invisible web of connected thoughts that can solve massive problems in seconds. So if everything is spinning, blurry, and messy inside a quantum computer, how do we ever get a real, solid answer out of it at the end of the day? This is the trickiest part of the whole thing. You cannot look inside the quantum computer while it is actively doing its work. If you peek at a qubit while it is in its spinning superposition, the magic instantly breaks, the coin drops to the table, and you just get a totally random 0 or a 1. It is like opening your eyes during a game of hide and seek before anyone is actually hidden. To solve this, scientists use quantum gates to create probabilities. Think of it like waves in the ocean. When two water waves crash into each other, they can either combine to make a giant superwave, or they can completely cancel each other out and leave the surface of the water perfectly flat. Quantum gates are designed to guide the spinning qubits so that all the wrong answers constantly crash into each other and cancel each other out, disappearing into nothing. At the exact same time, the gates force the correct answers to bundle together, getting bigger, louder, and stronger. By the end of the calculation, the only wave left standing is the right answer. When the scientists finally stop the computer and look at the qubits, the coins stop spinning, drop to the table, and point directly to the solution. It is basically using the strangest rules in the universe to solve the world's hardest problems.